لانه احنا بس حطيت كيف انه زي ما حكيت انه حطيت تفاصيل انه who's responsible for what. هسه برجيك كيف سويتها.
طيب لا اسمع مش راح اقدر اشوف هسه بلشت محاضرتي هسه.
بالليل لما تخلص
بالليل بنشوف نحكي مع بعض. طيب
ايوه بالليل كنت اقول لك بالليل اتصل علي بس جينا نفس الشيء.
يلا عليكم السلام. Okay, I was muted. Good afternoon, everybody, and let's start this class. Let me make sure I'm recording. All right. Okay. I think some of you asked me where to find the recording for this this class. Let me show you. Just a second. If I go to share the screen. Okay. So I'm. Can we see my screen now? Guys, can you see my screen?
I can see your screen.
Okay, good, thanks. So it's in the. So if I go, let me start from scratch. So this is my course. It's taking too much time here, so I better use the other one. Okay, so if I go to 304 fall 2002, right here, and then if I go to Capital Live and go to cloud recordings, so I'll find these two previous lectures, the one which I recorded by myself on September 2 on the outline of the course, and the last week lecture, which was September 9th. Now, unfortunately, this one, it has only one recording. The second file after the break did not record. For some reason, I couldn't find it. So probably it did not record. But that's where we find the recording for this class. If I go to, again, to previous class on spring, and I go to Capital Live and recordings, I'll find the recordings for all the lectures from previous semester. Those can be very useful if somebody wants to go ahead and see what's going on in this class. But those ones are from previous semester. Okay. So let me go back to my class here. And get out of this and start our lecture here. Last time we talked about some digital logic functions, some of the main functions which we use to simplify the simplify our logic equations. And I want to emphasize one more time the main reason for minimizing digital logic functions is to be able to minimize. So let me just write this down one more time. I need to So when we do some minimization, sometimes it's not really minimization, sometimes we use optimization, because you may minimize, but then you end up paying a price because you are forced to use certain gates which are more expensive or less reliable than others. So what we are saying here, the main objective or objectives, one, to minimize / optimize the cost of my system, and two, minimize or optimize. I keep the difference between minimization and optimization. Minimization is using the absolute minimal, let's say, time possible, but then optimization using the minimal time given the space, which means optimization what's called the space as well as the time and the cost. So we take into consideration those three things and minimize / optimize the space. Here I did not see. And when I talk about the space, it's about the size and how many, what is my real estate on my chip. So these are the three main objectives which we keep in mind. That's why so much effort has been done in this issue of the Boolean algebra and all the minimization and different types of converting formulas from one form to another form. Okay, so last time we started talking about putting the our algebraic logic functions in standard form. We talked about the min terms M0 through M7, or the max terms for the whenever we use the OR. So that we talked about. And then we said it's always good to put our logic functions in a standard form. And by standard form, we mean that, I think, let me see. Yeah, in standard form, we look at the variables which exist. Let's say if I have four input variables, A, B, C, D, then my standard form should include all the variables in my domain, which are the, let's say if I have A, B, C, D, then I need A, B, C, and D to be included in all of my logical terms, like this one. So a standard SOP expression is one in which all the variables in the domain appear in each term in the expression. And it will become obvious why we need that, because when we talk about optimization or minimization of our formulas, it will help a lot to have all my variables represented. Like in this case, if I have four variables and I have A, B, C, D here, I have A bar, B, C, D, so all four variables. And here I have A bar, B, C bar, D. All of them are represented in this equation. Whereas if I have only A, B, C or C bar, D bar, this is not standard, although it's minimal. This is better formula than this one, because here for A, B, C, I use only three inputs. This is an AND gate with three inputs, and this is an AND gate with two inputs. And of course, there are two inverters here, and there is an OR here, which has two inputs, the ABC and the C bar, D bar. This is much better. It's minimal. However, to get to this minimal one, to be able to find this minimal and to know that this is the most optimal thing I can get, I should have started with all of these four variables represented. Okay. So having said that, we say the standard SOP expressions are important in constructing truth tables and utilizing, here I will say utilizing the K-map, which will be probably today we might be able to discuss the K-maps, the simplification methods here. So first, we can construct truth tables much easier because truth table needs to include all the values of all the variables as well, and then we use it for minimization. Okay. So now to convert into standard sum of product. Now sum of product, I think I mentioned this again last time. This is a sum of product. This is we call this a product. So this we call it product. Product, which means it's a multiplication or it's an AND. That's the reason we say, that's why we call it product. This is product. And between this is a product, this is a product, this is a product, and then there is a sum between them. That's why we call it sum of products. Okay. So now in order to generate sum of product, the idea is very simple. The idea is simple. Let's say if I have, assume that I have 4 variables, and these 4 variables are A, B, C, and D. So these are my variables, and the sum of product, actually I have to modify my word, the standard sum of products. Standard sum of products should include the A, B, C, D in each term. That's the standard. So if I have AB or ACD or BD, this is sum of products, because you could tell AB is a product, I have ACD is a product, I have BD is a product, and all 3 terms are summed up, which means it is a valid SOP. So what's the deal here? However, we need standard form of SOP. Now, by standard form, we mean all variables should appear in each term. That's what we're talking about here. So let's say if I have AB, how do I convert this term to a standard form? Well, what is missing? What's missing here is the C and D. They are missing. Okay, the question, how do I add C and D? Simple. First, I remember from my axioms, which I talked about last time, I remember that C or C bar equals 1. So if I do AB, this is my AB, and I AND it with C or C bar, which means I am ending AB with 1, which remains AB. So I'm not really changing. So the term, the original term AB remains unchanged. That's the idea. It remains unchanged. Now, so in order to augment means add, augment the term AB with the variable C, all I have to do the following. So I'll do AB, I will do it this way actually, A dot B, and it with C or C bar. And if I use the simple distribution law, this becomes A, B, sorry, dot C, or A dot or AB C bar. So this is, let me take the dots out. So now I have added the term or the variable C to my AB term without changing the value, the original logic value of the term. So that's what I did. So I did augment it with a C. So now I have my C is there. However, I still need to augment the term, and I will do it this way, terms with D, because I'm missing D. Now it becomes simple. So now I work on the first term, ABC. Now I have these two terms. ABC is not standard. So I'll do ABC. I end it now with the D or D bar by the same way I did before. So now I have ABCD or ABCD bar. And also I do the ABC bar, which is a term that I have just done. I end it with, similarly with a D or D bar. And then I will get A, B, C bar, D, or A, B, C bar, D bar. Yeah. So now note that I got 4 terms here, 2 terms here, and 2 terms here. So with this AB, in order to augment AB with the C and D, I will get four new terms. Now, if I want to do the same for the ACD probably I just have to add it to augment it with a B. So I will have 2 more terms. With BD, I will augment it with an A and C, and then I have 4 new terms. So it will be 4 and 4, 8 and 2. So I have a total of 10 terms in standard sum of product terms. Okay. All right. So So this is the technique to do the conversion. And let me go back now to this one. This shows it in algorithmic manner. So if I want to write a program, a code to convert the sum of products into standard sum of products, note I'm talking about converting product terms which are already in sum of products. So if it's not in sum products, I have to change it to sum of products, then I will convert it to standard. To do that, this is the algorithm. That's what I have just said. Multiply each non-standard, which lacks one or more terms, by a term made of, what's this here? Something is missing. Oops. Of the sum of a missing variable and its complement. I think this is okay. And then the result is two product terms, as I said here. Then you repeat step one, keep repeating until all products are in standard form. That's exactly what I explained here, but that one is explained in more algorithmic terms, so we can computerize or automate the process. So let's do another example here. Okay, so let's do A, B bar C, A bar B bar, A B C D. Let's do it here. So again, let's so let's see. First step, we have to realize that we have, since we have A, B, C, D total, so we have 4 variables, which are A, B, C, and D. Okay, then we look at the terms. First term, it's missing the D. Second term, missing C and D. Third term, missing, not missing any. Okay. So let's see. First, let's work on ABC. What do we do here? Any help? So I need to do an ending with something. What do I end it with here? Quick help.
D and D not.
D and D not. Okay. Good. So that will give me 2 terms, A, B, C, D, or A, B, C, D bar. Done. So this is, let me mark this with green. So this is done. Whoops. Now the second one, I said the second term I have to work on it, which is the AB. So what is this missing? Any help? What I already said, it's missing the C and D. So what do I do here first?
You need to multiply it by C naught and C and D naught and D.
Okay, we will do it one at a time. So first we'll do it C or C naught or C bar, and that will give me two new terms, ABC or AB C bar, correct? So now I will say, now I have two terms with missing variables. These are new, which are the ABC missing D and ABC bar also missing D. So what do we do? ABC. We end it with, what do we end it with, ABC? Somebody is writing for me, helping me here. Yeah, okay. So ABC with D and D bar. Okay, good, thanks. That helps. All right. So this is ABC with D and D bar. That gives me ABCD or ABCD bar. And by the same token, ABC bar, I end it with D or D bar. So I got ABCD, ABC bar D, or ABC bar D bar. So now I have completed my work. And finally, my standard SOP formula looks like this. The first one, which I have here, is ABCD or ABCD bar, or from here, ABCD or ABCD bar, and the last two terms are ABC bar D or ABC bar D bar. Now I note that the ABCD is repeated twice, so I get this out of my way. Okay, this one. And ABCD bar, and I think ABCD bar is repeated. So let's make this, oops. We mark this with
There was a third ABCD in the original formula.
yeah. Oh, yeah, there is ABCD. I did not add it, correct? I had right there. Yeah, so it's ABCD. So I'll put it at the end because it was at the end. So we have the ABCD now. I have three of them, so I'll take only one because A or A or A is the same. So this is equivalent to ABCD. So now, and ABCD bar. So this is ABCD bar now. So I will just scratch it, I think. And ABCD bar, I have two of them. And this ABCD. So I still have A, B, C bar, D, or A, B, C bar, D bar. So it turned out I have 4 new variables, ABCD or ABCD bar, and all of them are in standard. This is standard SOP. Until now, until this point, I'm defying my own theorem, because my own theory is we need to do the minimization and the working on the logical function, so I can decrease or minimize my cost. Well, now here I had 1, 2, 3 AND gates, and 1 OR gates with 3 inputs. So here, let me do the one thing here. Just give me a second. I need to find my gates, which I need them in my work. Okay.
Hey, Professor, I have a quick question.
Yeah, go ahead.
Would it be 3 terms instead of 4?
What's that here?
Because you canceled out A, B, C, D not.
Yeah, A, B, C, D not. I have 2 of them. This one and this one. Do I have these 2? I canceled. So I have only one of them. A, B,
Oh,
C,
okay,
D.
okay, okay.
Yeah. So I'm left with 4.
Got you.
Okay. Just one second. I'm trying to find my gates, which I can just copy and paste. Makes my life easier to. Okay, never mind. Okay, so let's say this one, I'll just write it here. I need 3 AND gates. One with 3 inputs, one with 2 inputs, because that matters in terms of my expenses, and one with 4 inputs. And I need one OR gate with 3 inputs. Okay, so that's my original. Whereas this one here, my solution, I need 4 AND gates, each with 4 inputs, and I have one OR gate with 1, 2, 3, 4 inputs. So obviously, if I talk about the expenses, this is more expensive than this one. So that, as I said, it sounds like it defeats my purpose. But then if I take this further one step, I mentioned that I need the standard form so I can go to K-map and then do one more minimization. With the new minimization with the K-map or a tabular form, probably I will get much better than this one, either in terms of cost or in terms of speed. So that's an intermediate step. Putting the terms in standard SOP is not the final. It is one step to allow me to do much more optimization on my system. All right. That's the example which I just worked. Okay, now I think I also mentioned that the standard form allows me to write it in tabular form, where I do the truth table. For let's say if this is ABCD, there are 4 variables. So I'll take from 0, 0, 0 all the way to 1, 1, 1, which is from 0 to 15. That's all my binary values. And then I will take all of these variables. I write them instead of 0, 0, 0. I use the variables like A bar, B bar, C bar, D bar. Okay, that's what the 0, it means it's an A bar, and the 0, a second, it's a B bar, and so on. So if I write all of these terms from A bar, B bar, C bar, D bar, all the way to A, B, C, D, now I come to my, this is, assume that this is my standard assume I have a function like this one, ABCD bar, etc. I have 3, 6 terms. I find where is my ABCD. This is my ABCD. So I say, oh, the ABCD equals, in my function, it's 1 because it's a valid one. So if I have the A and the B and the C and the D, all of them will be ANDed together, and all of their values are present. So I have 1. I have the ABCD bar. Here is my ABCD bar, marked with red. So this is 1. A bar, B bar, C, D, which is this one. Which is 0, 0, 1, 1. And then the A bar, B bar, C, D bar. A bar, B bar, C, which is this one. So this is also marked with 1. And finally, A bar, B bar, C bar, D, this is also marked 1. And all negated, all nuts is also, this is 1. So this is my truth table. If I look at it now, I don't even have to look at these variables. I look at the ones, 1, 2, 3, 4, 5, 6. There are 6 terms which exist in my logical functions, and this is the representation in the truth table. So from my truth table, I can easily detect where my variables are, and all other positions are zeros. This is just happened to be, all of these zeros are sequential. Okay, this is just a repetition of what I have said. That's an example which I did it last semester. I'm not going to do it again. So now we'll just try to conceptualize what we've done in the truth table here. And this conceptualization. So if I take A, B bar, C, D bar, this is equal to one of them. Which one is A? So let's take A, B, C, D bar also. No. But for now, let's say A, B bar, C bar. If A is 1 and B is 0, so B bar becomes 1. Okay, that's, so if B equals 0 and B bar, therefore it's 1, and C is 1 and D is 0, so D bar is 1, then this value A, B bar, C, D bar becomes 1, 0 bar, 1, 0 bar, which is 1, 1, 1. So it's a 1 value. So that's what we mean by, in the truth table, A, B bar, C, D bar, which is this one. Now in this example, it's a 0, sorry. But if I take, as I said, the A, B, C, D bar, so I will take this A is a 1, ended with B is a 1, with C is a 1, and with a 0 bar, not 0, which is equal to 1. That's what this means. That's why we say it's 1. That's just the logical interpretation of A, B, C, D bar being 1 in the truth table. So this one here again, so it's 1, 1, 1, 1, 0 bar, which is equal to 1. Now, this is one standard form. There is another standard form which is called the product of sums now. Now, instead of saying sum of product, we'll talk about product of sum. Well, someone may say, what is going on? Why do we need all of this? Well, believe it or not, for the same function which we have, for the same logical function, if you use SOP or POS, it's going to make a difference in terms of cost. I keep emphasizing the cost because it's really, that's how people compete, based on cost and of course based on speed. So let's see just one more time the sum of product when I say ABC or ABC bar or A bar B C bar. This is sum of product. Here easily I can say I use AND gates for product and or for combining products. So this is, now when we talk about the sum, product of sum, which is product of sum as the term sounds, let me just use the same ones. So it's A or B or C. So that's a sum. And I take the product from there, the add. So this is A bar, A or B or C bar. And it with A bar or B or C bar. Okay. Now these are not equivalent, by the way, but these are two different functions, but they look like the same. This is a sum, A or B or C, that's a sum. A or B or C bar, it's a sum. A bar or B or C bar, it's a sum, and so on. This is a product of sum. So here we use OR gates. So I have first OR gate, second, third OR gates for sum, and I use an AND gate for combining products. What's the difference? In terms of technology, cost is different. And one of the exercises which we will do along will show, in fact, we'll be asking you to look up the cost of gates in the current market, and you will find there is a big difference between the cost of OR and the AND gate. Now that big difference, it could be in the percentage of a cent. That's not in dollars, but when you are using millions of these gates, that will accumulate for a large sum of difference. So cost is different, and also timing could be different. Because when we talk AND gate, we talk actually transistors and capacitors to build it in silicon, and the same thing about OR gates, and the way these gates are built, their cost is different and their timing is different. So it depends on what type of technology you want to use. And of course, some of them have advantages and disadvantages over each other. So that's why we need to study both so that we can decide based on our own interest and whatever optimization I want to use and whatever property I want to use out of these gates. Okay, so the product of sums, as I already mentioned, it looks like this. That's a sum. That's a summation. I know you can hear that cycle or car in the background. I don't even understand what good that makes when somebody tries to generate that interesting sound. Okay, so this is the product of sum. So the ones in red is an OR gate, and that's an OR gate, and then they are combined with an AND. And similarly, that's another one, that's another one, and this is also one. But these are not standard form. These are just product of sums. It's a product, which means I get the sums are the ORed, these are the ORed, and there is a product of them. But those are not in, as I said, not in standard form. In order to make them this is the product of some implementation which I was talking about. I have an OR gate here. That's an OR. That's an OR gate. That's an OR gate. One is for A or B, 2 inputs, B or C or D, 3 inputs, A or C, 2 inputs. And then there is finally the AND gate here, which combines all of them. And then I have the X. That's the implementation of my POS, which is yet, it's not in standard form. So now to go in standard form, we use the same technique and the same idea we did for the SOP. We have to see all the terms and all the variables in each term. If I see that my inputs include 4 variables, A, B, C, D, then I need, this is my first term. So call this my first term. My second term. And my third term. Each one has all variables. Each term has the 4 variables. That's standard. So the standard POS are important in construction, again, truth tables and utilizing same thing, the K-map simplification method. We can, then the question again, why use POS when I have SOP? Is it simply to go into more trouble, or because some digital logic engineer was able to create the second form? No, not really. It's because of the technology. Technology differences pushes us to use both standards. And in order to convert, we use the property. There is a property, as we did, remember, for the SOP, when you AND something with a 1, which is C or its complement, C or C bar, it remains the same, because A ANDed with 1 is an A, B ANDed with a 1 is a B. Here, we use this rule, like A or B, C, in order to include the term B into both. We do this distributive law, where this can becomes A or B ANDed with A or C. Okay, so it becomes, if I just add the term here A to both B, C, then I will get this equivalent. I will use this property. This property will be used to convert the product of sums into a standard. Okay, so step 3 now, I repeat step 1 until all resulting sum terms contains all variables, until all variables A, B, C, D are included in all of these terms. Okay. So this is, let's say, I have, this is not in standard form, A or B bar or C. Okay, so I need to convert, and B bar, C or D. That's not, I have 2 terms which are not standard. The third one is in standard. Okay, so now I want to use this property, use this rule. So I take the first one, A or B bar or C, and I AND it. I'm sorry, I add to it 0, because B ANDed with B bar is a 0. See, this is the trick here. In order to get a new term, So this is A or B bar or C. If I OR it with a 0, it stays zeros because A or a 0 is an A, B or 0 is a B. So if I OR my term with a missing term and its complement, then I should be able to include the last term in my formula or in my to include the missing variable in my term. So here my missing variable is D. So this is what happens. I will use this property. So this is, let me take this as A. This is as being one my X or my A or some two things B, C or D bar D. So it becomes this is A, B, C, A or this term. So ended with a D bar or the same term ended with a D, which is that's what I have here. That's my first. I got my first term here. And this is my second term. Okay. So let me do the exercise together here. So let's say if I have A or B, actually let me do it this way. A or B, no, not or, ended with B or C, ended with B or C or D. So I have these. So I have in my system 4 variables. We'll do the same exercise as we did here for variables A, B, C, and D. Okay, so now I think this thing thinks that it's enumeration. Okay, so now the first term A is missing B, C, and D. So let's work on it. Why is this? I'll say the term so let's try to add B to the first term without changing the value. So I will use A in this case. If I OR the A with a B and B bar, because B bar is 0, so that will give me AB, sorry, A or B ended with A or B bar. So I have now 2 terms, A or B, A or B bar. Now I have to work on the A or B. I have to augment it with a C. So I will just add to it C dot C bar. Similar, now I have A or B. Now the A or B becomes like one term. It becomes like the A. So this A or B and I move to the C. So this becomes A or B or C. Ended with A or B or C bar. So now I have three variables in my term. Now I have to work on the A or B or C, and I end it with D dot D bar. So I included now A or B or C or D, ended with A or B or C or D bar. So I got the first term taken care of. Just do the same thing I did before. And this has to, whoops, or maybe I don't need that anymore. Already explained it. So now if I work on the B or C, note that with the A, I have to do the 3 times. 1 times to add the B, and then to add C to both terms, and then to add D. Oh, I still have the one more to go. I still have the A or B or C bar. I need to add this to D bar. A or B or C bar or D. A or B or C bar or D bar. So I have these 4 terms. Got them from the first term A. Now when I do the B or C, I will have 2 terms. Am I correct? No, probably there is more, right? There is these 2. With the A, I added the B. I think I'm missing something, correct? Yeah, I'm missing the A or B bar. So I did the A or B, I finished the A or B. Now I still have to do for this one, the A. Yeah, because with one A, probably I have to add 4 terms. So it's A or B bar, which is this one. Now I worked on this guy. I got out of it 4 terms. And now if I work on A or B bar, I will get also 4 terms. So the A or B bar, again, with a C bar. That will give you A or B bar. Or C, ended with A or B bar or C bar. So we got this. Now we have to work on. So let me. Now I'll do this one. I will add to it D bar. And this is D. And this is D bar. Okay, so I got these. Now I still have the this one to work on. Plus D bar. Plus D. I think the one who did the copy and paste is genius guy to make our life easier. So I think now we have 8 terms. So the A generated 8 standard POS terms. Now if we'll go to the B or C, we'll generate 4 terms. And the last one, B or C or D, will generate 2 terms. So total of product of some terms equal 8 plus 4, 12 plus 2 is 14 terms. So 14 terms, if you come to think about it, now when we do the truth table in a second, this will be out of the 16 rows in the truth table, 14 of them will be marked with 1, and only 2 will be marked with 0. So this is a very, because why? Because there is an A which covers all the possibilities of the B and the C and the D. As long as A is there, then all the rest of the B, C, D, which are 8 terms, B bar, C bar, D bar, B bar, C bar, D, and so on. All of these will be included. So let me take a break here for a few minutes, and I will come back. I think you guys also need a break, I assume. So I will pause. Okay, let's get back to the session. So basically, going back here, finishing this this thing, if I do the B or C, I will add to it A, and then I will add to the new terms B or C. So this is so the B or C are going to be first, we'll get B or C or D. Ended with B or C or D bar. And then I will have the B or C or D. And I will put the A at the beginning without loss of accuracy. And A bar or B or C or D. So I have these two terms. Oh, for the B or C, sorry. And then I will have for the B or C, B or C or D bar. And I will end them with an A. And this A bar. So these are the four terms that are produced by the B or C. Then the last one, the B or C or D. This is going to be A or B or C or D, ended with A bar or B or C or D. So these are our terms. As I said, there are 2 and 4 and 8. There are total of 18, total of 14 terms. We can write them all together. Oh. This. and these. And this. Followed by these. And finally, so that's my function here. That's my product of sum in standard form with all of these 14 terms. Now, as for the binary representation, by the same tokens, if I look at the A or B bar or C or D bar, this is equal to 0 because I want this in the truth table where the ones belong to the sum of product and the zeros belong to the product of sums. So this becomes 0 only if A is 0, B is 1, so B bar is B is 1, so B bar is a 0, and C is a 0, and D is a 1, so it's D bar is a 0. And D equals 1. What's this here? I think there is something wrong in my system. Okay, we'll just do this again here. So when I say A or B or C or D, so this is equal to 0 only if A equals 0, B equals 0, C equals 0, and D equals 0. And by the same token, if I say A bar or B bar or C or D equal to 0, this is true only if A equals 1. So this is A bar is 0, B equals 1, C equals 0, and D equals 0. So when I do the truth table, so if I insert you would say 0, 0, 0, 0, 0, 1, 0010, 0011. Let's finish with this 0101. And this means it's A bar, B bar, C bar, D bar. It's A bar, B bar, C bar, D. A bar, B bar, C, D bar. A bar, B bar, C, D. A bar, B, C bar, D bar. Okay. So here, this is going to be if A bar, B bar, C bar, D bar is in my, which means I have A bar or B bar or C bar or D bar. So we'll take A bar or B bar or C bar or D bar. If this is in my terms, then this is going to be equal. If A is 1, oh, sorry, no, this is going to be A or B or C or D, and this is equal 0. Okay, because if A is 0 and B is 0 and C is 0 and D is 0, then all of these A or B or C, D or equal 0 and so on. So that's what we meant by this truth table difference, and this becomes clear when we talk about the conversion between SOP and POS. So let's do, now if I have SOP, how do I look at the POS, the equivalent POS in using the truth table? So the binary values of the product terms is given as standard SOP, and those will be are not present in the equivalent standard POS, which means if they are 1, the POS is going to be 0. So let's do the next. I will go to the truth table directly. So assume I have my function A bar, B bar, C bar. This is my SOP. So I'll get A bar 0, 0, 0. So this is going to be 1. That's my SOP 1 and POS 0. So that's how it will look like. So the ABC, A bar, B bar, C bar, and the A bar, B, C bar, which is 0, 1, 0, which is this one. It's a 1. And the A bar, BC, which is the 3, 0, 1, 1. That's a 1. And then AB bar C, which is the 5. So my sum of product equals 1 here. And the last one is ABC. So I have 1, 2, 3, 4, 5 ones from my sum of product. Now for the product of sum, all of these which are not ones, they are going to be product of sum, 0. So I'll look at the 0, 0, 1 here. So if I look at the at this 0, 0, 1, which is here, which is the A, B, A or B or C bar, okay, which is the A or B or C bar. Remember, this A or B or C bar is equal to 0 only if A is a 0 and B is a 0 and C is a 1, which is this one, 0, 0, 1. So this 0, 0, 1 is going to be 0. So that's what's my POS. In other words, when I do my truth table, if I fill the sum of products with ones like these, then the remaining are going to be the product of sums, even without doing any real conversion. I just look at them. And if I want to write them in a term of product of sums, 1, 2, 3, I have three sums, three products here. So it's going to be term 1. This is term 1. This is in red, term 2. And this is the last term, term 3. Okay, so now the first one, this is the second, and that's the third. So we said that the A, this for A or B or C bar to be equal to 0, this has to be 0, this has to be 0, and this whole thing C bar has to be 0. So if A is a 0, B is a 0, and C is a 1, C is a 1 because C bar is a 0, which means this 0, 0, 1, which is this one. Okay, so this is a 0. Now, if I look at this 1, 0, 0, the second one, this 1, which has my red term, if this one is a 0, which means for this to be 0, A has to be 1, which is true. B has to be 0, that's 0, and C has to be 0. So I have 1, 0, 0. So this 1, 0, 0, 0, and the last one with 1, 1, 0. So this has to be 0, this has to be 0, and this has to be 1. So it's 0, 0, 1, which is the, I'm sorry, this is 1 and 1 and 0. So the A here has got to be 0 because it's A bar. Okay. And if A bar has to be 0, which means A has to be 1, that's what it is, and B has to be 1, and lastly C has to be 0. So it's 1, 1, 0. So without going into this hassle, I just look at these at the sum of products, and I can fill the ones here, and the rest are going to be the product of sum for the same function. So, and these are equivalent. This and this, these are equivalent here. Equivalent means they perform the same function. So these things are equivalent. This one and this one. So if I have a system and I tell the guy implement for me this sum of products with these 1, 2, 3, 4, 5 terms, or if it's cheaper for you, do it this way. Give me 3 sums and have one AND gate that combines the 3. whichever is cheaper, whichever is faster. And that depends on the technology and the cost of the OR and the AND gates. Okay, so that's why we say I need to look at this truth table and eventually see where is my system, where is remember in the previous example which we worked a few minutes ago, this one, this has 14 terms for the product of sum. And if I put these on the 16 rows truth table with the 4 variables A, B, C, D, I will have the equivalent of those from sum of product, which has only 2 places where it's equal to 1, and the rest are zeros. So I can do, after going through all of this hassle, I can implement the sum of product, which is going to be much cheaper than the product of sum. So all standard Boolean expressions can be easily converted into truth table. Easily, we have seen that, using binary values for each term. Also, the standard SOP or POS expressions can be determined from a truth table. So we can look at the truth table and we can find their values. And going into truth table for the SOP expression equal to 1 only if at least one of the product terms is equal to 1, because we are talking about sum of products. If I have 10 products, one of them is 1, and the OR, because here you are relying on the like X or 0 or 0 or 0 equals to X. So if X is 1, then this can be 1. Okay. So let me make this 1. So if there is one term of these equals to 1, then my result is 1. So with the truth table, you list all possible combinations of the binary values, convert the SOP expression to the standard form, as we said, and then place 1 in the output column wherever that corresponds to one of these products. So something like this. This is my ABC, 3 variables, goes from 0, 0, 0 all the way to 1, 1, 1. If my function, my sum of products is A bar, B bar, C, that's 1. A, B, C, that's 2. This should be A, B bar, C bar. I think. And the last one is ABC. So I have 3 sum of product terms. The rest of them, if I start with this, so these are going to be 1, 1, 1, and the rest are zeros, and the zeros represent the product of sums. So now, how do I get the product of sum? If I start with this, that I already know, I have it, and I have the truth table, then I need to get the POS, the product of sum. I see, okay, all of these zeros, this is going to be A or B or C. This is going to be A or B bar or C, and this is going to be A or B bar or C bar, and this is going to be A bar, because this is 1, B, C bar, and all of this is ORed, and this is A bar or B bar or C, and the rest, of course, are the sum of products. So look at these here, the product term, either sum of product or product of sum. So this is my product, of sums. So this is the, as I said, A or B or C. That's the first one. Multiplied or ended with A or B bar or C, and so on. So I have 1, 2, 3, 4, 5 terms. I have 5 product of sum terms and 3 SOP terms. Okay, and that already simplifies my my job, because if I have a function, if you give it to me in product of sums, I'll find the standard form, and then the standard form of the POS would follow automatically, or the other way around. Give me the function in product of sum, and then I can convert that into fill the truth table, and it becomes my then I can get the SOP directly from the truth table. As I said, I can start with either SOP and go into the truth table, or I can go with POS and fill my table. So here I got the same expressions, which I got it from the from here. It's the same 0 1 0 0 1 0 0 1. Yeah, but I start with A or B or C. I start with these values here. I got the 0 0 0 0 0. Then the rest will be ones. So I start with the product of sum terms, fill in the table with zeros, the empty cells are set to 1, and these 1 cells will make up the sum of product. So either way, you can start with product of sum or sum of products. Okay. So to determine the standard, now SOP expression represented by a truth table, list the binary values of the input variables, as we said, from here 0 0 0 all the way to 1 1 1. You convert each binary value to the corresponding product terms. You place each one with a corresponding variable, and each 0 with a corresponding variable complement. So with the 1 0 1 0, A, B bar, C, D bar is going to be 1. If I have the 4 variables. Similarly, with the POS, we take the 1 0 0 1. This is going to be A bar, B, C, D bar. A bar or B or C or D bar is going to be 0 in this place. So you place a 0 here. This is just repeating what I have just said. And that's another example. There are 4 ones in the output variables here. Is 1 1 1 1. they come from these guys here, A bar, B, C. So 0, 1, 1, that's 1, 1, 0, 0, 1, 1, 0, and 1, 1, 1. So all of these, let me mark these with all, color them with red. So those red ones are my sum of products. I can write them here. And the rest, the other ones, the 0, 0, 0, which is equivalent to A or B or C, and this is A or B or C bar, and this one is A or B bar or C. This one or the last one is A bar, B, C bar. All of these, of course, or A bar or B or C bar. So these two are equivalent. So that's one has 4 terms and this has 4 terms. In this case, if you were looking at the from the cost effectiveness, you may end up in saying, look, I have either way SOP or POS is going to be equivalent to me, except with the use of OR gates or AND gates, depending on what is it that I am interested in. So here for 3 variables, number of entries is going to be 8, 2 to the power 3. If I have n equal 5, then I have 32 entries in the truth table. And if I have 6, I will have 64 entries in the truth table. And that's, of course, once you go into 6 and above, you need computerization. You cannot simply do it by hand. It's going to be very difficult. Okay. So I'm not going to go into the K-map now. What I will do for the rest of the time, probably you can do it. You don't have to finish it right now, but I will leave you with an exercise on SOP conversion, doing standard format SOP, standard format POS, and then going from SOP to POS and from POS to SOP. And I will leave that exercise for you. It's about maybe 30 to 40 minutes of your work, or could be less, but that's where I leave it now. And next time I will do the K map. So I will do my slide here. It is going to be okay. Do you have any questions for me? Okay. Let me save this guy into and upload the file. Okay, I'll see you next week, guys. And in a few minutes, you will see the assignment on the Canvas, and it will be due before class next week. Okay.
All right, thank you, Professor.
For sure. Sure. Thank you all, and I will see you next week.
I'll see you next week, Professor.
Yeah. Bye.
Thank you. See you next week, Professor.